First off, over here, I wanted to talk a little bit about what the names of each of these parts of a radical are, mainly because I say radical and you guys go, what? And I have to say square root. But square root is only one type of radical. The radical is any time you see that symbol, that's called a radical symbol, the little house. This right here, n, that's called an index. That tells us which type of radical we have. So when we don't have anything there, it's called a square root. If we have a different number like a 3 or a 4, we call it a third root or a fourth root or a fifth root, whatever the number is. Okay, the number in here is called the radicand. So the radicand is just what we call whatever's inside the radical. And these parts are going to start playing a role in about 2-3 days. But for right now, we're going to look over square roots and how to simplify them, but we're also going to practice with different indexes. So what happens when we're taking a cubed root, or a third root, or a fourth root, or a fifth root, and so on. So here we have, so again, this is a square root. We can imagine there's a little 2 there. It's kind of like an imaginary 1 in front of an x. We have an imaginary 2 for a square root. So what's the square root of 25? 5. And so if you remember, how did we break those down? We did our tree. We have a pair of 5s. So 2 5s gives us an answer of 5. When we go to something like a third root, or a cubed root is what that is sometimes called, we're going to do the same thing. We're going to get it down to its prime factors. So what are two numbers that multiply to 125? 5 and 25. Okay, and then let's break it down further. 5 and 5. So because in a square root we looked for groups of 2, this is telling us how many we're looking for in our group. So here we're looking for a group of 3 numbers. So do I have 3 of the same number? Yeah, I have a group of 3 right here. So that means my answer is just the 1 5. The cubed root of 125 is 5. Just how when we had a pair, we brought it out as just 1 for every pair. In a cubed root, you bring out 1 for every group of 3. Okay. So let's do another one, cubed root of 64. So start by breaking it down. So 2 numbers that multiply to 64, 8 and 8. And then 8 and 8 can both break down. 4 and 2, 4 and 2. 4 breaks down to 2 and 2, and 2 and 2. So from the bottom of my tree, do I have any groups of 3 numbers? We have 2 groups of 3. I have this group right here, and I have this group right here. So that means I can bring out a 2 for each group, so my cubed root is 4. So in the next one, we have a 5th root of 32. So how many are we going to look for in our group? 5. So let's make our tree. So what are 2 numbers that multiply to 32? 8 and 4. Okay. 8 becomes 4 and 2. 2 and 2. 4 is 2 and 2. So do I have a group of 5 of the same number? Yeah, I have this group of 5 2s. So that means it comes out as just 1 2. Okay, any questions so far? Thank you. I believe you sit next to Justice. Okay, any questions so far on radicals that are not square roots? Max?
So why is number 4 too.
So what, I had a group of 5 what? What number did I have a group of 5 of?
2.
That's why. So just like here, how we had 2 5s, so our answer was 5. Because we were looking for a group. So whatever number you have 3 of or 4 of or whatever, this is the number that's telling us how many have to be in our group. So if I can find 5 of a number, then that number will come out. If I can find 3 of a number, that number will come out. So I had 3 2s, so it came out there. My other 3 2s came out right there.
Is it like there's not enough for one group?
Then same thing we did with square roots, and we're going to do one like that. If there's not enough, it stays inside. So just like when we did square roots last semester, if it wasn't a perfect square, it stayed in the square root. If it's not a perfect whatever, it stays inside the root. Okay? Okay, so what we're going to start looking at now are those ones, the ones that are not perfect. So any questions on the ones that are perfect before we get into the ones that aren't? Okay, so 32, what is our root? What's our index? If it's not written. It's a square root. So sometimes we like to write a 2 to just remind us we're looking for groups of 2. You don't have to write it. It's just something you can do. So then let's break down 32. So we have 8 and 4, 4 and 2, 2 and 2, 2 and 2. Now what about x to the third? How do we break down x to the third? What does that mean? How many x's do you have? 3. So I'm just, whenever you see variables, I just list them out in expanded form. So I have my 3 x's. Okay, we're looking for groups of 2 because it's a square root. So there's a group of 2. There's a group of 2. I have something left over. Over at my letters, I have a group of 2 with something left over. So everything that grouped up comes outside. So 2, a 2, and an x. What didn't group will stay inside the square root. So we can multiply what's outside together. 4x square root 2x. And that would be your simplified radical. Okay, that's the added part for today is variables as well as not necessarily just square roots. You might have a cubed root or a 4th root or a 5th root thrown in there. Okay, so let's do these next 2 before we get into 8, 9, 10, 11. So how many are going to be in our group for number 6? 3. We're looking for groups of 3. So then let's break down our number, 500. What 2 things multiply to 500? 5 and 100. And then 2 things that multiply to 100?
50 and 2.
50 and 2. 2 things that multiply to 50? 25 and 2. And then 25, 5 and 5. And then for our variable, how many m's do we have? 2, 3, and 4. Okay. So groups of 3. Do I have any? What? 3 5s, and I heard 3 m's. Okay, so then that means I'll have a 5 and an m outside my root. And when we write our radical, we have to make sure the index matches what we started with. So we have to write cubed root and make sure that it's inside this little part here and not out front, because out front means it's being multiplied. So I am going to be picky about how you write that 3 there. It needs to be in that little crook. So then multiply what's left. So we had a 2 left over, another 2 left over, so that's 4, and an m left over. So we'd have 5m cubed root 4m as our final answer. Okay, so number 7. Anyone remember what we do with the number on the outside? We just leave it out there until we bring other stuff out there with it, and we'll multiply it at the very end. So it's just going to kind of tag along till we get to the very end. So let's start with breaking apart 21. 7 and 3. And then we have 2 A's and 3 B's. So how many am I looking for in my group? 2. So do I have any groups of 2? We have 2 A's and 2 B's. What, any numbers? No, and that's okay. So the 5 is going to already be out there, so I just bring that down. I can put an A and a B outside as well. And then what was left over? 7 times 3, so we multiply those back together. And then a B. And that would be your final answer. Okay, so how are we doing with simplifying radicals that aren't just square roots? The more practice you get, the quicker it becomes. But those of you, you'll see kind of why the tree is kind of helpful. When we did square roots, a lot of you guys were able to pick it up quicker. And you can still do that. There's faster ways to do it, but for right now, this tree is probably the easiest way to think about it. Something else when we're doing these radicals, how many of you guys know all your perfect squares up to 12? Okay. Do you know what I mean by that when I say all your perfect squares up to 12? Anyone not know what I mean by that?
Like 8 to 4?
No, so like, what is 2 times 2? 4, so 4 is a perfect square. What is 3 times 3? 9, so 9 is a perfect square, all the way up to 12 times 12. So knowing that 144 is a perfect square, 121, 100, 81, 64, 49, 36, 25, so on and so forth. Okay, you guys should know those, and that when you see it and they say what's the square root of it, it should come quickly to you. You want to try to add to your arsenal up to 15, because up to 15 becomes really common. So it's just 3 more numbers. So what's 13 times 13? 169. What's 14 times 14? 196. And then 15 times 15? 225. Okay, those are other ones that become really common. So if you add those to the list of perfect squares that you know, it'll just help things go a little faster as we move on. Another thing you might want to also look at learning or memorizing are your perfect cubed numbers. So in other words, numbers that when you multiply them by itself 3 times. So like what's 2 times 2 times 2? 8. So 8 is a perfect cube. What's 3 times 3 times 3? 27. So 27 is a perfect cube. 4 times 4 times 4? 64. 5 times 5 times 5? 125. So if you can at least know some of those, usually about, I would say 1 through 5 is a pretty good start. If you can do, or sorry, 2 through 5, if you know those ones, those will just help you with cubed roots go a little bit faster. Do you have to? No, because you can always fall back and do your tree, but if you know those, when you see them, it'll help you go a little bit quicker, okay? So the last 4 problems we have here with radicals, we're still simplifying, but we're doing some other operations as well. So anyone remember what we did when we had 2 square roots multiplied together? You multiply them, and they stay inside the square root. And then what did we do after we multiplied them? Made our tree to simplify. But what is the square root of 16? 4. So this is one where if you know it's a perfect square, do you really need to make the tree? No. And this is where if you know those perfect squares or those perfect cubics, they'll help you go a little quicker because you're not always making the tree. Okay, so 9, 10, and 11 we haven't really done, but they kind of go right in with our simplifying. How do we add square roots? You can only add them if the square root is the same. Because it's like variables. Can you add x plus y? No, they're different. So if they're different, we can't add them. We can have fractions, yeah. But what we want to do first is simplify both square roots to see if they really are the same, they're just not simplified yet. So can we simplify the square root of 8? Yeah, we have 4 and 2, 2 and 2. We have a pair of 2's. So square root of 8 becomes 2 root 2. Do these have the same square root? Yeah. So then how can we add them together? By adding the numbers in front. So we can put our imaginary 1 in. So what's 1 plus 2? 3, and then square root 2. It's just like if that square root were an x. It'd be like saying, what's x plus 2x? 3x. It's just now it's our square root instead of an x. Yeah.
So if it doesn't have a number in front of the square root, then add a 1.
Yeah, it's kind of like x. What's the coefficient of x? 1. So it's the same idea. It's that imaginary 1 that we put in. So some people like to put it there so they remember that it's a 1. If you don't need it, then don't do it. Okay, so what about number 10? Start by simplifying both radicals. So we can't simplify square root 7 any further. That's as simple as it gets. But what about square root of 63? 9 and 7. So we have a pair of 3's. So are those like terms? Yeah, because they have the exact same square root. So when we add them, we add the numbers in front to get 5 root 7. And last one, I think. We can't subtract quite yet. We have to simplify the square roots, because unless these are the same, we can't do it. So break these down. This time we have both radicals to simplify. So how can we simplify square root 32? 8 and 4, 2 and 4, 2 and 2, 2 and 2. So we have a pair of 2's, a pair of 2's, and 1 left over. So we have the 2 that's already out there. So that's the one I brought down. A 2 for each one that paired up with a square root 2 inside. We have 4 and 2. So here we'll have the 5 we bring down, the 2 from the pair, and the square root 2 that's left over. So what's 2 times 2 times 2? 8 square root 2. 5 times 2 is 10, square root 2. They're like terms because the radical is exactly the same, so we subtract the numbers in front. So what's 8 minus 10? Negative 2 root 2. Oh no, I do have a couple more, sorry. Okay, that's pretty much it for the new stuff. The last thing I just wanted to recap with you is, again, something we did last semester. I just wanted to refresh your memory on it. So any questions on the adding like terms? Chase?
How would the answer be shown if, like, on number 10 it would be root 8 and then 1 would be like root 7?
Then you would just leave it like that. You'd have to leave it as root 7 plus root 8 because you can't If you can't do anything, then just simplify and that's your answer. You can't actually combine them. Okay, the last ones that I wanted to go through are just recalling how to move a square root from bottom to top, because your assignment has some of these on it. Do you remember?
We should do root 5 to the top and root 5 to the bottom.
Yeah, so remember we rationalized by, whoops, not a 2, a 5, by multiplying root 5, or whatever the square root is, to both the top and the bottom. So we get square root 5 over, and then what happens when we multiply the same square root together? The square root 25, which just becomes 5. You guys remember how to do that from last? We did it right at the end of the semester with our trig stuff. Same thing on 13. Multiply top and bottom by root 5. So 2 root 5. And again, we multiply only the radicals together. The 3 just hangs out. Square root of 25 is 5. So what's 3 times 5? 15. And there would be your answer. And then last one, we multiply top and bottom by the square root of 3. Multiply the radicals insides together. And we end up with square root 15 over 3 after we simplify the square root of 9.